Everyone, welcome to my channel Steady Junction, and in this video we are going to see some of the numericals of chapter work and energy. So let's start. First of all, we'll revise some of the formulas and units. So the formula of finding kinetic energy is half mv square, where kinetic energy is denoted by E, and in the subscript we have K is the kinetic energy of a body of mass m moving with a velocity v. If m is in kilogram kg, v is in meter per second, E subscript k is in joule. Second, work done is equal to change in kinetic energy. Work done is equal to half mv square minus half mu square, or W is equal to half mu square minus half mv square when U is greater than V, and in the first part where V is greater than U. Now let's see our first problem. How fast should a man of mass 60 kg run so that his kinetic energy is 750 joule? Here we are given the mass of the man, that is 60 kg. Kinetic energy of the man is 750 joule. We have to find V, the velocity of the man. So we'll apply this formula and we'll get 5 meter per second. So first formula we are to apply. Find the mass of the body which has 5 joule of kinetic energy while moving at a speed of 2 meter per second. Here kinetic energy of the body is 5 joule, speed is 2 meter per second, and mass, again with the same formula of kinetic energy half mv square we can find. So the answer would be 2.5 kg. Now let's move towards the third problem. So a player kicks a ball of mass 250 gram at the center of a field. The ball leaves his foot with a speed of 10 meter per second. Find the work done by the player on the ball. Now the ball which is initially at rest gains kinetic energy due to work done on it by the player. Thus, the work done by the player on the ball, right? Work done is equal to kinetic energy of the ball as it leaves his foot is work done is equal to kinetic energy is equal to half mv square. So mass is, we'll convert it in kg. 250 gram is equal to 0.25 kg and V is equal to 10 meter per second, and then by applying half mv square formula we get 12.5 joule as the answer. A body of mass 5 kg initially at rest is subjected to a force of 20 Newton. What is the kinetic energy acquired by the body at the end of 10 seconds? So we are given the mass 5 kg, initial velocity 0, force is 20 Newton and time 10 seconds. Now we can find acceleration by acceleration would be equal to force upon mass. So 20 Newton by 5 kg is 4 meter per second square. Now let V be the velocity of the body after 10 seconds. So we are by the first equation of motion we have V is equal to U plus 80. So 0 plus 4 meter per second into 10 seconds is 40 meter per second. Then kinetic energy acquired by the body is half mv square. So half into 5 kg into 40 meter per second square, that is 4000 joule. Now let's move towards the fifth problem. A bullet of mass 20 gram with a velocity of 500 meter per second strikes a tree and goes out from the other side with the velocity of 400 meter per second. Calculate the work done by the bullet in joule in passing through the tree. So it's similar. Mass is given. We'll convert it in kg. Initial velocity we are given. Final velocity this time we are given. Now work done we'll find by second formula. Work done is half mv square minus half mu square. But here our final velocity is less than initial velocity. So we'll apply half mu square minus half mv square. So by calculations we get the work done 900 joule. Now let's move towards the next problems. A body of mass 4 kg is taken from a height of 5 meter to a height 10 meter, find the increase in potential energy. Now we are given mass as 4 kg, increase in height of the body is 10 meter minus 5 meter because it's from 5 to 10, so 10 minus 5 is 5 meter. So increase in potential energy, the formula for finding potential energy is mgh, right? So 4 kg into 10 meter per second and 5 meters, so it is 200. Then another format it is given, another method, so you can also follow that method. Now an object of mass 1 kg is through a height h, its potential energy increases by 1 joule, find the height. So the method is clearly given, it's similar to the first question. Let's move to this question. A 5 kg ball is thrown upwards with a speed of 10 meter per second. Find the potential energy when it reaches the highest point. Calculate the maximum height attained by it. So we have the mass, we have the speed of the ball, we can calculate kinetic energy by half mv square formula. So then we have to find the potential energy. So when the ball reaches the highest point, its kinetic energy becomes 0 as the entire kinetic energy is converted into potential energy. That is, potential energy is equal to 250. So now let's find the height. So in order to find the height, we have again to use the formula. Potential energy is equal to mgh. So we have potential energy, we have mass, we have g, we can find height. So by dividing, we find the height as 5 meter. So next question is the similar question. So do practice this question. Here's the solution for your reference. Now let's see the next one. A body is thrown up with a kinetic energy of 10 joule. If it attains a maximum height of 5 meter, find the mass of the body. Very easy question. In the similar way, you have to find it. A rocket of mass 3 into 10 raised to power 6 kg takes off from a launching pad and acquires a vertical velocity of 1 km per second and an altitude of 25 km. Calculate its potential energy, kinetic energy. So we have the mass of the rocket, velocity, then we have the height. So simply we can find potential energy, that is mgh. Then kinetic energy, half mv square. So very easy question. So let's see some other questions based on power. A body of mass 40 kg runs up a flight of 50 steps, each of 10 cm high, in 5 seconds. Find the power developed by the boy. Mass is given, total height is given, time is given, work done we can find by mgh, then power is work done upon time taken. So here's the answer. Then is next, a car of mass 2000 kg is lifted up a distance of 30 meter by a crane in 1 minute. A second crane does the same job in 2 minutes. What is the power applied by each crane? Do the cranes consume the same or different amounts of fuel? Neglect power dissipation against friction. So mass is given, height, time is given, time 2 is given. We can find the work done. Then power we can find because just the difference of time is there, work would be same. So you can see the whole solution over here. Problem 3. What should be the power of an engine required to lift 90 metric tons of coal per hour from a mine whose depth is 200 meter? So we have the mass, right? Then we have the height and time. So work done we can find, and then power would be work done upon time taken. How much time does it take to perform 500 joule of work at a rate of 10 watt? So we have been given work and power. Time can be found out similarly. Time would be work done upon power. So 50 seconds is the answer. Calculate the units of energy consumed by 100-watt electric bulb in 5 hours. So we have given the power. 100 watt is 0.1 kilowatt. Time is 5 hours. And power would be work done upon time taken. So by calculations, we get the answer as 0.5 units. Problem number 6, that's the last. A lift is designed to carry a load of 4000 kg through 10 floors of a building, averaging 6 meters per floor in 10 seconds. Calculate the power of the lift. So we are given the distance covered, 60 meters. Then we have the time, 10 seconds. Force we are given, and velocity we can find by distance upon time. Now power of the lift is force into velocity. So 240 kilowatts would be the answer. So this was the last question. So I hope you all enjoyed the video, and if you did, then please like the video and subscribe to the channel.